Down our symbols, we do our crisscross method. Why do we do the crisscross method? To make the total charge equal to 0. Why do we want the total charge equal to 0? What does that do for each individual atom? Makes it stable. When each atom in there, when the total charge on the compound is 0, all of the atoms that are involved will have gained or lost enough electrons so they all become stable. Okay? So we write our formula down for this one, ladies and gentlemen, Mg3N2. Okay? That is our formula. Okay? Now, again, it has a total charge of 0. Why? Well, we take the number of magnesiums times the charge of each. So the number of magnesiums here is 3. The charge on each is a +2. Sorry about that. That means that the total charge is a +6. We would do the same thing for nitrogen. The number of nitrogens times the charge. So there are 2 nitrogens here. The charge is a -3. That means the total is a -6. That means this compound has a charge of 0. Never fails. Never fails. Now, the only way that the crisscross method can let you down is how? What?
The symbols?
Nope. Nope. Symbols are determined by what elements there are. What is the one way the crisscross method can let you down, Christopher? What's that? It's not reduced into its lowest form. So, again, there are a lot of different ways of writing these compounds so that their charges could be 0. We want only one way to write a compound, so that Phoebe writes it one way, Maddie writes it one way, Eric writes it one way, we all write it the same way. To do that with binary and any other ionic compounds, we always put them into lowest terms. By putting them into lowest terms, that will allow us to make sure that we are all using the same compounds. Now, the only place where the crisscross method may let you down, ladies and gentlemen, is if you get to a compound like this. We do the crisscross method here by taking this 4 and bringing it down by the sulfur. We take this -2 and bring it down by the tin. Now remember, ladies and gentlemen, we never write negative numbers. You can't have a negative amount of an atom. So these subscripts at the bottom need to be positive numbers. So we put the 2 here. We put the SN4 there. Charge is 0. No doubt about that. But these are not in the lowest form. So we end up having to reduce these into the lowest form so that we can get the correct formula, SNS2. Questions? Okay, the name of this one, what is it?
Magnesium nitride.
Magnesium nitride. Very good. What is the name of this one? And be careful, it needs a Roman numeral. I have never heard this class this quiet ever. Well, let's start out. What's SN?
10.
10. What's its charge?
It's
Angel. Did I catch you stretching, Angel, or? I'm sorry. It is not a -4, but you are close.
4?
Yeah. Now, why don't we need to undo the crisscross method and stuff here?
because we were given its
We
charge,
were given its charge when we wrote the formula.
but we still have to write it in its name.
But we still have to write it in its name. And again, the only reason I'm making you write it in its name is because I'm telling you we need to put it in the name. Okay? So then what would the rest of this compound be? Very good. Questions? Questions on anything?
How do we know we need to write the Roman numeral?
Again, I will let you know. In other words, I will say that these need Roman numerals, or For this one, please put the Roman numeral to indicate the charge. Now, please remember, I had somebody today who took the quiz, put Roman numerals with everything. We don't need them with everything. We only need them with the elements that we cannot tell what charge they are. That only happens with tin and lead and the elements that are in groups 3 through 12, except for zinc, which is a +2, and silver, which is a +1.
And that's because you give.
And that's because I gave those to you. Okay? Questions?
So what if if you didn't give us that, those would be written in Roman numerals too?
Which ones?
Silver and
No, they wouldn't, because they are ones that, like sodium, the reason we don't put a Roman numeral after sodium is because it's always a what? +1. The reason we don't put a Roman numeral after calcium is because we know calcium is always a +2. The only reason we use Roman numerals is if we are not sure of the charge. So again, we would never put a Roman numeral with zinc, because what's the only charge zinc can have? +2. So if there is only one charge that something can have, we don't need Roman numerals. We only need Roman numerals when we are writing the name of something that could have more than one oxidation state or charge. Okay? So again, I will let you know when that is happening. Questions? Okay. Well, today, ladies and gentlemen, we are going to move on to our next thing. And our next thing, ladies and gentlemen, is this. Our next thing is what is called a ternary ionic compound. Okay? This is slide 19 in your notes. Now, on slide 20, I don't think you have anything to type in, do you? Okay, good. So let's just talk about what this means. A ternary ionic compound has 3 or more different elements, and it is formed by gaining or losing electrons. Now, how do you recognize in a formula if there are 3 different elements? 3 or more.
Wouldn't you have the name of all of them?
No, a formula would be like H2O. How do you, what? How many?
3.
If there are 3 or more capital letters, ladies and gentlemen, in your formula, you have to be having something that has a ternary ionic compound. A binary will only ever have 2 capital letters. 2 capital letters means it's binary, which is why it's very important, too, that we don't capitalize something we are not supposed to. Okay? We're looking for capital letters. Capital letters say, okay, this is a binary compound, or this is a ternary compound. Okay? So, now, again, you can still talk about cations and anions, because we're still talking about something that is positively charged, something that is negatively charged. Okay? But a polyatomic ion has to be involved. That is how we get a ternary ionic compound. Now, on the back of your periodic table, ladies and gentlemen, right over here is a list of very common polyatomic ions. Now, tell me something you notice when you look at that list. Something that stands out to you, something that is unique, something that is different. Give me something, please, when you look at it.
There's a letter above, like a -2.
Okay, they have to give you a charge, so again, we're going to put that number above as a superscript. So the -1, the +1, the -2, the -3. They've got to give you the charge because these are ionic compounds. They are an ion, which means they have a charge, so they have to tell you that. Good, what else? Lydia, I'm sorry. Lydia raised her hand, sorry. We'll come to you right afterwards.
Most of them are negative except one.
Yeah, most of them are negative except the second one on your list, ammonium. Ammonium, ladies and gentlemen, right there. Ammonium is a positive polyatomic. Now, there are more than ammonium out there. There are. And there are more than these. These are just some of the very common ones that we're going to use in class, okay? But there are ones that are positive. What that means, ladies and gentlemen, is because they are positive, they will be where in your compound? Who do I got to yell at? Because yesterday we had this problem. Where are the positive ones always? They are written first. Remember some of you yesterday when you were rolling dice, you would put the negative one first and then the positive one? Can't do that. Positive one's always got to go first. And ammonium is a positive one, but there's no what in it?
No metal.
There's no metal in it. There is no metal in it. Okay? So we got to be careful. All right? Good. Give me, Ruby, you had something else.
That's a bonus.
Okay. What else do you notice?
What's parentheses CN?
Okay, some of them do have parentheses in them. And we are going to have to use parentheses sometimes with polyatomic ions. The reason you use parentheses, why would you put something in parentheses in math and then put a number in front? So like 3 parentheses x plus y.
So you can do bonus.
So that you can distribute it. It means 3x plus y's, correct? That's what it literally means, right? Well, the same thing here. When you put something in parentheses and then put a subscript by it, it means there's that many of those in there. So that CN group in there, there are 6 of those or however many, whatever that is. Here's what I will tell you. I don't think I have ever given anyone a compound with those in it. Okay? They exist. I don't think I've given compounds with those. Yes, Ruby?
Their names, most of them end in 8.
Good. Their names end in 8. So now I give you a name of a compound, and it ends in 8. People will go all over the place. Well, where is carbonate in here? It's not. Flip it over. It's on the back. If it ends in ATE, it's going to be on the back of your sheet, ladies and gentlemen. That's where you will find that group.
There's also
Now, here's where it gets a little confusing. Thank you, Ruby. Some of them on the back do end in IDE, hydroxide. Ends in IDE. That will not be a binary compound, because we still have to put something else with it. Now, every binary compound ends in IDE. But what this now means is not every compound that ends in IDE is binary. Good. So all binary do still have to end in IDE. But you may end in IDE and not be binary. I'm sorry, if I were to do this, I would have named them something else.
How would you know?
You have to basically learn, okay, where's hydroxide on here? Which elements ending would become hydroxide? What does hydroxide sound like?
Hydrogen.
And
Oxygen.
oxygen. Turn it over, it's on the back.
Oh, because they're combined.
Because they're combined. Okay? I wish there was an easier way for me to tell you that. But here's the good news. The other ones that end in IDE are cyanide. We won't do that one hardly ever. Ferrocyanide, again, we will not use those. So hydroxide, we will use quite a bit. But it's the only one that ends in IDE that we will use, really. Okay? All right? So good. Those are the things that we wanted to point out. And they are on the back of your periodic table. Now, polyatomic ions could still either be a group of atoms covalently bonded together, acting as a single ion. So all of these things together, NO3 together, gives you a -1 charge. Okay, the whole group together.
Does that mean that there's 3 nitrogen and
No, that
oxygen?
means there is 1 nitrogen and 3 oxygens. Think about that. If that were just a formula, NO3, we don't put anything by the end because it means how many? 1. Okay? But when you put 1 nitrogen and 3 oxygens together, they get 1 extra electron and they have a -1 charge overall.
Is there a specific formula to get,
There are ways that you could figure out what the charge would be. We're not getting into that unless you want to take AP Chem.
an AP Chem?
No, haven't had it in the last 2 years. Probably not. I don't know if we'll ever have it again. Anyway, there is an explanation for it. We're not getting into it. Okay? So, what does covalently bonded mean? Anybody know?
They share valence electrons.
Thank you. Now, what kind of elements do that? Well, there's only 2 kinds. Metals and Non-metals. Metals are trying to do what with electrons?
Or, give up.
Lose them. So if you're trying to lose something, would it do you any good to share that thing with someone else? No, because it's kind of like you still got it, right? But non-metals are trying to do what? Gain. So maybe Phoebe will not give me an electron, okay? But maybe we'll share an electron, like her lunch. We could share her lunch, and then it's like we both have it, right? Right? Okay? Now, she could just have her lunch, be greedy, and keep it all to herself. But if she were to share it, it would be like we both have it. Correct?
Would that make you happy?
What?
Would that make you happy?
No, because she got mac and cheese. And then, anyway. All right. So we're going to treat them like any other ion. What I mean by that is if it's an NO3 group that's a -1, we're going to treat it like fluorine, which is also a -1. Chlorine, which is also a -1. Bromine, which is also a -1. The whole group, we're going to treat it like it's a single atom. Okay? The whole group, we're going to treat it like it's a single atom. And never, ever, ever, never, ever, 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 never, Joshua, when?
Never say never.
Never, ever, ever, never, ever change the group.
Never say
Do not
Never.
never change the group, ladies and gentlemen.
never.
If it's an NO3 group, you do not change that. You do not make it N2O6. You do not make it NO5. You do not make it NO16 with a -12 charge. You do not change the group, ladies and gentlemen. You do not change the subscripts. However, what if you want more of that group? Well, then, ladies and gentlemen, you need to put parentheses around that group.
What?
Because by putting parentheses around it, you are changing how many of the groups are there, not the group that is there. Okay? Questions?
Yeah. What do you mean? When do we add parentheses?
When you're going to have to put a subscript by the group. So I'll show you. Okay? All right. First of all, MgCO3. Kaylee, is that binary or ternary, and how do you know?
Binary.
Why?
I just guess.
Good, because you're wrong.
I
Okay,
know.
I hate to tell you this, but you're wrong with this one. And I put you on the spot because I made you do the first one. So Ruby says she knows. Go ahead.
A ternary.
Why?
Because magnesium.
No,
Okay.
keep it simple. I'm a simple person.
Because that's a 3 at the end, which means
No. What? 3 capital letters. I'm a simple person. That has 3 capital letters. That's a ternary compound. How many capital letters in the one below it?
2.
So what is that?
9.
That's binary. That's binary. Eric, SR3, PO4 in parentheses 2.
That's a turn. I don't know how you say it.
Ternary.
Ternary.
Ternary?
Yes.
Ternary.
Wait.
It's a poly.
Huh?
Ternary.
Yeah.
Okay.
That's three.
Okay, it's a ternary. I'm agreeing with you.
Oh.
I don't know why you're getting all excited. BaCl2. You have 8C. Be confident. Say it loud. What?
Binary.
Yeah, it's absolutely correct. Only 2 capital letters. It's binary. NaC2H3O2. Maddie. What? Ternary. I know, it's a weird word. You'll get used to saying it. Here's the good news. Later on, we really don't care. I just want you to recognize it right now. Okay, good. Good. LIAS. Lydia. Why? 2 capital letters.
Lies.
PbOH in parentheses 4. Angel. This one over here, not you over there. Ternary. Good. AgNO3. That angel over there, not this one over here. Ternary. Good. COO. Ben. Why? 2 capital letters. Good. FeCl3. Jade. FeCl3.
Binary.
Good. Binary. Now, be careful. Again, Cl looks a lot like
A capital I.
Ci. Okay? A lot of the fonts that we use nowadays don't put the lines at the top and the bottom of an I anymore. Okay? But here's what I will tell you. I will not give you a compound with carbon and iodine in it. Okay? Won't do that. What?
Does that make sense?
It can be. I mean, it is possible, but we won't do it. NaCl is binary. What about MgOH in parentheses 2, Irving? Which makes it ternary. Very good. Very good. So now that we can recognize them, when you go to write names for these, ask yourself, am I in the binary system, which means the name has to end in I, or am I in the ternary system, where the name probably ends in 8, but maybe still I?
8 that up.
Okay. Good. You're thinking ahead for acids. I like that. Good. Cation, ladies and gentlemen, is a positive ion. Some examples, NH4 plus 1. Now, there are other positive polyatomic ions. That's the only one we're going to work with in this class.
So if a cation is a positive ion, then the onion is a negative ion?
An anion is a negative ion, yes. Yes. Now, there are lots of negative polyatomics. CO3, carbonate. OH, hydroxide. PO4, phosphate. There are a lot of negative polyatomics. So normally polyatomics will be at the end of your compound. But understand, this one would be at the beginning. All right. So here we go, ladies and gentlemen. Here's the good news. I'm changing no rules on you.
You're just
None.
crossing the other number.
We're changing no rules on you. Write the symbol of the cation in the charge. We said write the symbol of the metal in the charge. The metal is a cation. I'm not changing the rule on you. Write the symbol of the anion in the charge. But now the anion may be a group. We still write it, put the charge with it. We do the crisscross of the superscripts into subscripts still. Why?
Makes it 0.
Makes the charge on the total compound 0 still. Very good. Makes the charge on the compound 0 still. We still drop signs. The numbers that are subscripts cannot be negative numbers. And since they have to be positive, we don't put a positive sign. We still remove ones. We don't show ones. But here's the one kicker. If you are going to put a subscript by a polyatomic ion, you have to put the polyatomic ion in parentheses. The entire group, you put it in parentheses, and then you put your subscript afterwards. Okay? Now, here's the thing. Crisscross method still lets you down one time.
You have to simplify.
Yes, but do not simplify something within your polyatomic. Simplify the number that is outside of the parentheses. And I will show you what we mean by that. Okay? Simplify the number outside of the parentheses. Not part of the polyatomic. Matter of fact, there is one. Oxalate. Look up oxalate on the back of your periodic table, ladies and gentlemen.
I see it.
What is its formula?
C2O4 and then -2.
C2O4. 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 What's wrong with that?
Okay. The number.
Make it simple. I'm a simple person. C2O4. What's wrong with that?
Not simplified.
It's not simplified. But guess what? It's a covalent compound. It doesn't have to be. Covalent compounds do not have to be simplified. Okay? They do not have to be simplified. All right? Why? Because we're sharing electrons. Again, we're not going to change that group ever, though, because that's one of our rules for here. We don't change that group. C2O4, we leave it as C2O4. We're never going to change that. Okay? All right. Total charge on a compound must always be 0. That we're not changing. So here we go, ladies and gentlemen. We have sodium a +1, carbonate a -2. Okay? So we do our crisscross method here, ladies and gentlemen. We do our crisscross method just like we've done before 1,000 times or more.
Wait, are we gonna play the table game again with the dice?
We'll see what we see when we see what we saw, but right now, no. All right, so here we go, ladies and gentlemen. So we take this positive 1 by the Na, we put it by the CO3. We take this negative 2 by the CO3, we put it by the Na. So Na what?
Minus 3 and then the minus 2.
Where'd you get the minus 3 from?
Not, I said minus 2 and then 3.
Science.
So Na what?
So
Two.
Na, whatever this dude said.
2.
2.
Okay, this dude said 2. Now what?
3.
3.
It's not true, Mr. Brown.
Well, again, I'm willing to go with what you tell me. What's the next thing that we would do?
Plus 1. Well, just 1.
So just like that, right?
Oh, plus 4.
Where's the 3?
Thank you, Christopher. You changed the group. What's the group?
3.
CO3. Don't ever change the group. Now, what number am I supposed to be putting by this? Where do you get a 4 from?
I don't know, actually.
What number am I supposed to be putting by this, people? Come on, help me out here. What number were we bringing down in the crisscross method? A 1. Do we ever write ones?
Oh.
So what do?
You're like,
You're done. That's your compound.
Oh.
You're done. Now, somebody name me Na.
sodium.
Now, somebody find me the name for CO3.
Carbonates.
Oh, that makes sense.
There's your name.
Carbonate.
That's it. That's your whole name.
Wait, so how do you make
It?
soda? Because you know it's carbonated?
Rocket science.
Where's the 2?
Where's the 2? What 2?
Negative 2.
I don't think it's still there.
Carbonate. Said carbonate. It has a negative 2.
Good. Yeah, I did.
Yeah.
What is the name of this compound?
Magnesium chloride. Wait. Well, normally it would be the chloride.
What's the name of it?
Chloride.
Well, where's the 2 in that, Christopher?
Oh.
We don't have to worry about the numbers. There's only one way to write these. So we don't have to worry about the numbers that are at the bottom. Okay? So we didn't worry about the 2 when we wrote these names. We're not going to worry about the CO3. The CO3 group is carbonate. So there's no reason to try to identify that there's a 2 NAs. We know that because we have to balance off charges. Okay? Wonderful, excellent, great, amazing, incredible. Good job, good job, good job. All right. So now Ca and OH. What comes down by the Ca?
Nothing.
Nothing. Well, it would be a 1,
Yes.
but we don't write it. Okay? What do we do with the OH?
Put it down and leave it. Don't change the subscript.
Okay, but what about the 2 here?
Forget about it.
We forget about it. Just forget about it, ladies and gentlemen. We just leave it. We don't even think about it.
Oh, you don't change it. Oh.
He's wrong.
Wait.
That was sarcasm.
Oh.
2.
Yeah, exactly.
Right, we do that.
You want
Right?
the name 2? You want the name 2?
Isaac, you're shaking your finger at me. What's the matter?
The OH needs to be in parentheses.
Thank you. Thank you for remembering that we can't change the group.
I said that.
You just changed the group by making it OH2 instead of OH.
I said that.
What did you say? Because apparently you said it so quietly that only the people around you didn't hear it.
I said that before you brought down the 2, you don't change it.
Okay, so how do I put a 2 there then?
Because someone told you to put it 2.
It's crisscross.
What am I missing? What are we missing, people?
Parentheses.
parentheses.
Oh.
Why?
This is why. Why? Here's why, Christopher. CA is a +2. OH is a -1. Sorry, wait. -1, right? What would that be for a total? +2 and a -1. What's the total?
1.
1. That's not 0, is it?
Yeah.
But if I bring a second OH group, now what's the total?
0.
So, sorry.
It happened.
So I've got CA, one of them. How many OH groups?
2.
So I put them in parentheses to indicate that there are 2 of those groups there.
Oh. Okay.
Okay? That's what we meant when we said you have to put the group in parentheses.
Okay, that makes more sense now.
Okay?
Thank you for helping me understand.
All right, here we go.
Wait, there's more?
Sure, we got 3 minutes yet. I'll bet you we could get this and 2 more done.
Bet, let's go. I bet you $10. Let's go. Actually, I don't want to bet.
Well, I'm sure not betting with Angel because he would welch out on the bet anyway.
Or he's a loser.
So, okay. Crisscross method.
Okay.
This 3 goes by the PO4. This 3 goes by the GA. So we get GA what?
3. Friends, PO 4 3.
And we're good, correct?
Yeah.
No,
Angel, why not?
I don't know.
Are we good?
Yeah, you do.
No.
Why are
Now
we
we're
Oh,
done?
you gotta simplify.
Thank you. Here's where we talked about. We are simplifying, not anything inside the parentheses, the number outside. Since they're both 3s, we can simplify.
Goodbye.
Okay? And we have to simplify.
So what happened to the parentheses?
Well, we don't need them now because we're not putting a number by the PO4 group. So we only put the parentheses. What in the heck is going on? We only put the parentheses if we're going to put a subscript by the group.
Oh.
When we ended up reducing the subscripts and it became a 1, the parentheses go away.
Oh.
I don't need parentheses if there's no number by it.
Now that makes sense.
And by the way, I will mark it wrong.
What?
Okay?
Yes.
And by the way, ladies and gentlemen, you need to go a little bit slower, some of you, on your quizzes, because
Y'all got it wrong.
cobalt is not symbol C.
It's
Silicide is not symbol S.
It's SI.
Okay? And some of you are getting the wrong formulas because you're not taking the time to look on your periodic table and get the right symbol. Okay? Now, others of you are doing other things wrong, but that we'll worry about on Monday.
Stop, please, though. Oh, my God.
Calculators, back where they belong. Find their home. Hey, you're naughty boy. Where's my hat? I'm holding you to it. You got to come to school tomorrow and bring me half. I don't want those, but I will rinse it out and get rid of them. The only reason I don't is these are not strong enough because they're not carbonated. So I use like this. Hey! Oh, sorry, Jake. Go. Sorry. It made me all nervous there. I thought Xavier was trying to escape. Go away. Go. Get out. Goodbye. I have an answer. You want to go first or shall I? I thought you were leaving your computer.
Oh. Question right here.
Yeah.
Intensive. Boiling.
That's not a property. Boiling, melting points.
Isn't it the same
My
thing?
bio-
No, boiling is an action, not a property.
What do you mean?
Boiling is something that is actually going on. That is a change, not a property. Boiling point is a change, is a property, sorry.
Oh, boiling meant. Oh.
It meant melting or boiling point, sorry.
Ooh.
Okay? So,
So, I get it.
okay, good. Thank you for understanding, sir.
Of course.
You still did okay.
I did it right.
You did. You did. Keep it up. Keep it up. Now go away, get out. Go. The door is that way. Find it, use it. Goodbye.
Bye.
Adios. Arrivederci. You gotta go now. Have a good weekend, sir.
Vai, vai, vai. Vai, vai, tiro. Vai, vai, tiro.